Still have 4 not here yet. Oh. So you can join the Jamboard already. This morning we have done the tutorial 4. Is it finished? Let's see. This morning. We have done until question 12. Finish, huh? Then tutorial 4 done already. So we can do tutorial 5. Okay, copy the question. Now, I think the tutorial 5 need to wait for tomorrow lecture. But I think here we can do a few until the machine congruence. I have taught until machine congruence, right? You still remember? Do you still remember where I stopped lecture? I think you have done until machine congruence and also the input string. So by right, it's able to do until question 5. Question 5. So here, no, you are same one group 1, no? Why same 2 group 2 student ask me now got class or not? Same 2. This is same one group 1. Same one group. Copy the question to the Jamboard for tutorial 5. Want me to assign the question or you do it yourself? Any volunteer? I think this class got volunteer, right? You have the link or not for the Jamboard? If no, then I send again. For those who just joined. Anyone doing? No. Then I assign lah. Okay, question number 1 is just to draw the diagram of the this table. This is a step transition table, so we need to know what is the effect after all the input ABC. So the step here, we will see what will happen after each of the input. So the table here show you whether it will change to another state or it will remain as the same state. So we just follow this table and draw the diagram. Okay. So this table we call it as a state transition table, and the diagram draw refer to this table is a state transition diagram. So for the first question, Abdullah, you do part A. Nino,
No, I haven't do it.
oh, you do it now? Okay, can you do it now?
No, this is understand.
Huh?
No.
Draw the diagram only from the table given.
Yes. Which one?
The question 1, Abdullah, you said? Abdullah, you cannot do, right?
No.
You be careful with your assignment.
Okay.
So you do A lah.
Okay.
Kayao here. Kayao, what happened to this morning? Are you here? You absent, right?
Yes.
What happened? Sleeping?
Yeah.
Oh. Then you do part B,
Okay.
This morning no class, I thought you have other class. You also absent, can draw on the spot here. Use the pen there. This pen can use. Okay, then you can draw the diagram. And then question number 2. This is to also draw the diagram, and after that need to construct the caution machine. Zhong Han, question 2. And then number 3, also the same like number 2. This one is to construct the one more part you need to do for number 3 is you need to show that it is a machine congruent. Okay, in the notes you have the example how to show it is a machine congruent, so you can follow that one and do question number 3.
Okay.
Then question number 4, also do the show the machine congruence, and after that draw the diagram. Number 4.杨金。Number 5, Jai. Okay, you can do until question number 5.
早上几点？7点半。7点半巴士。4点半到 TBS， 然后叫报归。3点多。坐11点半。
Who is doing this?
5个小时。
Can write your name?
OK。
我在睡觉。我一半夜要做广播编，他10点开工，他早上5点就走车。哦。5点要走车的时候，你应该是刚刚起吧？没有，我刚刚睡吧。刚刚睡不要起，因为刚刚睡了。好像 assignment 还是？你不是去新加坡玩咩？啊？你没有去新加坡玩？没有啊，没有去新加坡。我回家吧嘛。回新加坡我的家。我陪他们在那边。证明哎，爽哎，可以找证明玩哎。我找可文。对，每天都讲不能。我没有 try。try 啊，就 try 不能，不能的。那就下一个吧。下一个谁加选？我在 record screen， 没有办法。online class 有老师进院，我都没有在听。你穿到这样长裤去图书馆？ 什么 assignment？做 website 啊？他有教你们用什么东西
Okay, then number one.
？ASP 啊
So this one
，C# 啊，
is part B. Write your name
那
there.
个 web application development。
So the first question we want to draw the diagram by looking at the table here. So you see the first one is S0 here, right? And then this is the input given to the machine. What happened to S0? This is the stats, okay? What is the condition of the machine at that particular time? After they receive input A, it changed to S1. So from S0, it changed to S1. So when you draw the diagram, right, S0 after A, you just draw the line A here and then go to S1. This is input A. Okay? So look at the S0 after the input B. It will remain at S0. No change, right? So we just draw a loop, go back to S0. Okay, input B, yeah? And then for the input C, S0 will change to S2. So here, S0, input C, go to S2. This one, go to S2, right? So this is the input C. Okay. Now, same also for the S1, the step 1. Step S1 is after the input A, it will go to S0. So at the S1 here, you need to go to the S0 after the input A. And since after input B, it is still the same, also go back S0. So you write two input together. No need to draw two lines. Okay, just draw two input together. And input C here, it will change to S1, remain at S1. So input C here, remain at S1. For the S2, you have S2, S0, and S2, right? So input A and C, it will go back S2. Then you just draw a loop back for A and C, go back S2. And for S0 is after input B, go back to S0. So here, back to S0 after input B. Okay, so this is the state transition diagram for the first part. And then for the second one, also the same, refer to the table here. After input 0, what happened to the S0? This one, no change, right? So you just draw the loop back to S0. After the input 1, it will go to S1. So here go S1. Then also S1, it will remain at S1 for input 0. So loop back. And after input 1, it will go to S2. So this one, input 1, go to S2. Okay, just refer to the table and draw the input. Abdullah, understand or not?
Yes.
The rest, any problem with this? Just look at this is the input, the 0 and 1 here is the input. And what happened to all the steps? Then just follow. So don't confuse the input. Jason, what do you mean?
No question. Next question.
Oh, okay. So this one understand, Next question. This one number 3. Okay. Question number 3 for this is they ask you to show the R is a machine congruence. So that means in the table given here, right, you need to show by using the table like this. After the input 0 and 1, what will happen to all the steps? You must make sure that all these steps remain as the same class. So if they remain in the same class, then you can say that the relation R is a machine congruence. Okay, so for this one, if you look at this relation given, the R given, you can see that the relation is actually 1, 1, 1, 4, and then you have 4, 1, 4, 4. So if you convert to the matrix, right, you will get this matrix like this. 1, 1, 1, 4, and then 2, 2, 2, 3, 3, 2, 3, 3, 4, 1, and 4, 4. So this is from the set R given here. Okay, and if you want to show that this is a machine congruence, you can convert this to the table like this. After the input 0 and 1, what happened to 1, 4, and 2, 3? Now, why we put 1, 4, and 2, 3 in different groups here? Why like this, Cynthia? Why do you put 1, 4, and 2, 3 like this?
I look at the matrix. The one is 1001, and the 4 is 1001 also, and the 2 and 3 is 0110. So I put them together.
Yeah. Okay. So we can actually look at the matrix here, or you can look at the relative step also. If you find the relative step of 1 and 4, they are the same. So that means we can group them together. The same also for 2 and 3. You can see from the matrix here, if you see that they are the same, right, then that means they can be in one group. And after you divide them to the group like this, right, you will need to see after the input 0 and 1, what happened to all these. And we get this from the table here. Okay, so you can see the input step. The first one, input, the step 1, this one, after the input 0 and 1, right, it will go to 1 and 4. So here, 0 is 1, input 1 is 4.
iPad 有
Let's see. Okay, you can see from here, the input 0 and 1, it will go to 1, 4, right? And then for the step 2, step 2, after the input 0 and 1, you see this is 3 and 2, 3, 2, right? So here, 3, here, 2. Input step 3 is 2, 3. So here you get 2, here is 3. Okay, and for the step 4, after the input 0 is 4, after input 1 is 1. So you have 4, 1 here. Understand? So that means after the input 0, for 1 and 4, it will remain here, 1, 4. For 2, 3, it will remain here, 3, 2. Because now we have 1, 4, 1 group, 2, 3, 1 group. So if this is in one group, no matter it comes from 1, 4 or 2, 3, as long as it is in either one of these, okay, then it is a machine congruence. So how do we want to write the conclusion for machine congruence? You need to say the related steps. What are the related steps here? The related steps are 1 and 4, 2 and 3. They will remain related. Okay? Remain related means the 1, 4 will remain 1, 4, 2, 3 will remain 2, 3. Or if you put here 2, 3 also never mind. You put 1, 4 here also never mind. As long as after the input 0 and 1, they remain in the same class. Okay, so this is what we mean by R is a machine congruence. You need to conclude this. The related steps, which is 1 and 4, 2 and 3, they will remain related after they receive input 0 and 1. So we can conclude that the relation R given is a machine congruence. Okay, this is what they ask you to do. Show the R is a machine congruence. So you must show this table to show that they are remain related after they receive input 0 and 1. So you need to write this conclusion. And this is the first part. After that, they ask you to construct the state transition table for the corresponding caution machine. So here you already have a table, but this is not the caution machine. Caution machine is the one that you already divide to classes. That means that this one I will put as one class. This one I will put as one class. So I will write 1, 4 with one class only. Class 1. I will write 2, 3 with one class only. Class 2. Okay? So normally we will follow the first name. If the first one is 1, then you just put the class 1. So this is what we call as the caution machine. Whenever you put the table for the caution machine, right, you need to put the bracket here. This bracket is to show that it is a class. Okay? So we call this as the caution machine state transition table. The original table, this one, given one, is the state transition table of the given machine. Given machine. This one is the caution machine. Okay? After we divide two classes. So after you divide these two classes, you have input 0, you get 1, input 1, you get 4. But here we don't write it as 4 because the 4 now is the same group with 1. Okay, so we already used 1 to represent this whole group. That means whenever you have 1 and 4 inside here, you will write it as 1, class 1. Okay, we use class to represent it. Same also for 2. If you use 2 as the second class, right? So after the input 0 and 1, you see here is 3 and 2. Okay, so we will not write the name with 3 also. We will use 2 to represent the second class. So here, 3, you will write it as 2. Okay, and here is 2. No change. 2. Now remember, put in the square bracket to represent that this is a caution machine. Okay, so that is the diagram of the caution machine. No, this is the table of the caution machine. And after that, they ask you to draw the diagram of the given machine and the diagram of the caution machine. So you need to draw two diagrams. One is the given machine. As I say, this table is the given machine. So you need to draw the diagram like question 1 just now. You draw this one. This is from this table. Okay, you can see that the step 1, after the input 0, it will go back to 1. And then after the input 1, it will go to 4. Okay, so you follow this table to draw this diagram. And the diagram of the caution machine, you need to draw referring to this table. Because you only have 2 classes, right? 2 classes, so you refer to this table. You just draw this one. Remember to put the bracket. So class 1, after the input 0 and 1, it will remain at class 1. So just put look back, then input 0 and 1. Class 2 also remain at class 2. So here, go back, 0 and 1. So this is the diagram of the caution machine, which is M over R. Okay? Understand? So this is the question for number 3. How do we show that it is a machine congruence? Every time when you want to show machine congruence, this is what you need to do. You need to show this table, write this sentence after you're done. You make sure they are in the related steps. Okay? Then this is the transition table from here. How do we group it to 2 different groups? And the diagram of the machine comes from here. And also the diagram of the given machine comes from this table. So you can draw the diagram referring to the table. Sometimes the question didn't ask for this table, they only ask for the diagram. So it's up to you. If you can straight away draw the diagram without this table, then you can do so. But if you cannot, then you better do this table first. Then only do it. question for this? Now for the question number 2, the question also asks you to draw the diagram and then construct the diagram for the corresponding construction. So the first part is just to draw the diagram, right? This one, the first. So we have S0, S1, S2, and S3 from this table. Okay, then you get this. So S0, 0, 1, 3, 0, 1, 3. S1, we have 0, 1, 2, 0, 1, 2, and then 2, 3, 0, S2, S2, we have 2, 3, 0, and then S3, we have 2, 2, 0, S3, 2, 2, 0. Okay. Altogether, how many we have? We have 12, right? So this is the diagram. And construct the diagram for the corresponding caution machine. This one also like just now number 3, you can form the relation given here in the matrix. Okay, from this relation here, then you can form this. And from here, you can see the 0 and 1 in one group, 2 and 3 in one group, right? So 0, 1, 2, 3. Then you can see here the 0, 1 after input A, B, C. What happened? So you can see from the table here, this is after input A, B, C, 0, 1, 3. So here you will get 0, 1, 3, right, for A, B, C. Then S1, you have 0, 1, 2. So here, 0, 1, 2. S2, 2, 3, 0. So here you have 2, 3, 0. And S3, you have 2, 2, 0. So here, 2, 2, 0. Okay. And this is just to construct the diagram for the corresponding function machine. Then that means we don't need to show that it is a machine congruence. It means this question itself already machine congruence. Okay. They remain in the class of S0 and S1. Here, this is 0 and 0. This is 2, 2. This is 1, 1. This is 3, 2. 3, 2 also in the same class. 3, 2 is same class. And then this is 3, 2 also. And this is 0, 0. Okay. So we can draw this diagram from here, from this table. So we have two classes. One is S0, one is S2. So 0, 1 class, S2, 1 class. Put in the bracket. And follow here lah. This one, S0, after the input A, you have 0, S0, right? So here input A, go back S0. After the input B, it will go to S1. So go back, S1 is the same class with S0. So we will also go back S0 because they are in the same class, 0 and 1. And then after input C, it will go to S3. S3 is inside this class, which is S2. So that's why input C, it will go to S2. Okay. Then for the S2, you see after input A, this is remain at S2. So input A, go back S2. This one is after input B, it will go to S3. S3 is still inside this class, right? So we will still go back S2, okay, for input B. We don't go to S3. If you use S2 for this class, then you go back S2, no S3. And the input C here, it will go to S0. So go back S0. S2 after input C, go back to S0. So you get this we call as the corresponding Gaussian machine diagram. Okay, this is the diagram of the corresponding Gaussian machine. This is the diagram of the given machine. Diagram of, you can label it. This is the diagram of Gaussian machine. Okay, I hope I explained like this, you all can understand already. If you still have questions, you can ask. Okay, understand? Question 2 and 3. As I told you just now, if this one you cannot straight away draw from here, you can form the table first. So if you form the table, you will have S0 for the first class here, and the second one, because it is S2 and S3, so you can form the S2 as the second class. Okay, then the input, you have ABC, right? Then just write 3A, B, C. Then the S0 after the input A, you look at this table here. It is S0, right? So here you put S0. Then the input B, it will go to S1, but S1 and S0 are the same class. So here is still S0. And this input C, right? The C here is S3. But S3 is the same class with S2. So we will write here as S2. Because we use the 0 and 2 here. Okay. So input C after the input the S0 after the input C, it is S3, this one. But S3 now is the same class with S2. So we just write S2. And for S2 here, after you look at these three here, S2 after the input N, what is the step? S2. Right? This one? You see or not? See, this is S2. And then the input B after the input B, S2 change to S3, right? This one S3, right? But S3 is still the same class with S2. So here we still write S2. Okay. And for the input C here, S2 after input C, it will go to S0, right? Here, this is S0. So S2 after the input C, it will change to S0. Then, if you want to draw the diagram, you refer to this table, will be easier. So you have 0, 0, 2 for S0, you see? 0, 0, 2, and this one is 2, 2, 0. So S2, 2, 2, 0. Okay? No response in your class. Okay. Okay, next. Well, this one, I think ask a student to explain what they do is easier. So see you understand how to do or not. Just now who do this? Yongjing, is it? Is it Yongjing? I have explained a few questions already. Right, Yongjing? How do you divide the classes here? Yeah, can you tell from the answer you show, how do you divide the classes, the partition? Hả, Yongjing? Yeah, lor. It didn't on the mic, is it? It talk. Are you talking? Huh? Run already. Well, wait, see. Yeah, Yongjing, just on your mic. Just tell me how do you divide the classes here? Just now I already explained so many. from where? We see from where? Where is he? He's very shy. Then soon you know how to help him. You help him. Who know how to divide? You are very shy also. So everyone also shy like this class, is it? No lah. Using set for matrix. Choose the same one. Oh, he told you, Jackson. So from the matrix here, we have S0 here, right? And then this one is S0, 1, 2, 3, 4, S4, right? So we have these two the same one, right? And you just see, put together this one and this one. Then you put together one class. This one, 0, this is S1, and this is S5, right? So 1, 5 together. These two, 2 and 3, same also, so put together. Then this input 0 and 1, after the input 0 and 1, so we see from the diagram, if they don't give you the table, they will give you the diagram. So from the diagram, you can see after input 0, what happened to the steps, S0. After the input 1, what happened to the S0? So it will change to S0 and S1. That's why here, S0 and S1. And for the S4, so you look at this diagram. Where is S4? Here. So input 0, go back S4. Input 1, go S5. So S4 and S5 lah. For S1, input 0, go to S3. Input 1, go to S5. So we have 3 and 5 here. S5 also the same. Input 0, go to S2. Input 1, go to S1. So we have 2 and 1. You follow or not? So this one, the table here, get from the diagram. And of course, the first thing is to divide these groups from the matrix. Okay, from the matrix, you divide which are the same, which are not the same, then put it in the different classes. Then after you divide, right, you need to make sure what happened. The question asks you to do what? They ask you to show the relation R is whose matrix is given is a machine code. So you need to show this. This one, show that the relation R on S, relation R on S is this one, on the stat, all the stat, whose matrix is this one, is a machine congruence. So we need to show the groups is the machine congruence. So that means after you divide it to the groups like this, and then you need to decide here, is it the same class or not? Here you have 3 groups, right? And you need to make sure all after the input 0, input 1, this is in the same group. They cannot be separated. Here, 0, 4 is in one group, right? 1, 5 also in one group. This one, 3, 2 also in one group. 5, 1 in one group. 2, 3, 1 good. 4, 0, 1 good. So you must make sure all the steps after the input 0 and 1, they will remain in the related steps. Related steps. Related step means 0 and 4, 1 and 5, 2 and 3. Either one of them here. If let's say here is S3 and S5 instead of S2 here. Let's say this is S5. Then what happens? Is this the machine congruence? No, right? Yes. Cannot be a machine congruence anymore because 3 and 5 is not in the related steps. Okay, they are not related. So in that case, it is not a machine congruence. Then we need to divide the classes again. So that one we will look at it tomorrow. So here, all of them are remain related after they receive the input 0 and 1. Then we can conclude that the R is a machine congruence. And of course, the question asks you to draw the quotient machine. So you can put it in the table like this first. So the table, again, like just now, you have one class here, S0, second class, S1, third class, S2. So we put it as this. And the input 0 and 1, this one is 0 and 1. So we have 0, 1. This one is 3. 3 is S2. So we have 2 and S5 is S1. So here is 2 and 1. Okay. So you get this 2 and 1. And the last one is 2 and 4. So 2, 4 is S0. So we have this one. This is S2 after input 0 is what? S2, right? This one should be 2, right? S2 after the input 0 is S2, correct? So it should be 2 and this one is 0. So here should be 2. S2 and S4 is S0. So this one is S0. So after you have done the table, you can draw the this diagram of the quotient machine. So 0 is 0, 1, 1 is 2, 1, 2, 1, and 2 is 2, 0. 2, 0. Okay. This one, the diagram, why we have double circle again? Remember what is the double circle? The acceptance step, right? So how do we know that this one we need to put a double circle? Look at the question here. This table, this diagram. Here they give you S3 double circle, S2 double circle, right? So that means these two are the acceptance step. Okay. So when you have this one of them in the diagram here, you need to follow with the double circle also. Okay. Because 2 and 3 is in one group. Okay. This is the question number 4, which is to show machine congruence and also draw the diagram of the quotient machine. So as I say, if you can have this without the table here, you can straight away draw this from this table, no problem. Okay? Because this question they don't ask for the step transition table for the quotient machine. If they ask, then you must draw this. But if you need this to draw this one, you can construct it first. Okay. One of them. The classes we have here. If here you only have one out from S2 and S3, you only have one of them here. Then when you draw this, you only draw double circle for S2. Okay, if you have two in the table here, let's say after you divide the class, right? Let's say here is S2 and then this one need to divide again. Then these two become two classes already, right? Then in that case, when you draw the diagram, you need to draw S2 and S3 also. And both also need to put the double circle. It depends on how, after we divide, what happened to the step. Understand? Because now we not yet teach until the back part, where sometimes we need to divide this again. In this case, you don't need to divide already. So this two is considered as one class. Then no problem. But for tomorrow class, after you see, sometimes the input 0, right? Here they are not in the same group. So if let's say this one is S2, this one is S5, they are not on the string congruence, right? So one is S2 here, one is S5 here, different group. Then in that case, we need to divide this again. So if that happens, then this diagram, right, need to have two classes of S2 and S3 separately already, instead of you do one S2 only. Then in the table here, if you separate this, then your class here will have S2 and S3. Okay, now that one tomorrow I will teach. So this is question 4, right? Question 5. This is to find the question 1b. Refer to question 1b and then find the input string. Very small. This one 0, 0, 1, 0, 1. 0, 0, 0, 1, 0, 1. We do from left to right. When you read the string from left to right. 0, 0, 1, 0, 1. Okay? So when you write in the function format, you will do from right to left. Meaning here it should be 0, 0, 1, 0, 1 like this. If you write in the function form, but if you put in the string format like this, 0, 0, 1, 0, 1, then we will read from left to right. We do from left to right. Okay? If you put it in a function, every F here, and then we will do it from right to left. So when you write the 0, 0, 1, 0, 1, this one will be 0, 0, 1, 0, 1. And this one after the input 0, S0, what happened? This one we will refer back to our question 1. Question 1b. You look at the table 1b. 1b. Look at this table. Okay. S0 after the input 0, what happened? It is remain at S0, right? So here S0. That's why you see after the input 0. This one can go to here. You can see after the input 0, right? The table for first question. Okay. Look at this first now. So 0, 0, 1, 0, 1. So this is step by step. If you straight away do for table here, you can straight away read also actually. See how we read? See like this. 0, then remain at S0, 0 again, and then 1, come to S1, and then come to S1, 0, S1, then 1, S2. So the input string for 0, 0, 1, 0, 1, right? For the question 5 part A, you can straight away read from here. 0, 0, 1, and then 0, 1, which is S2. Okay. So you get S2, right? Then this one S2. If you don't write the answer also, never mind. You don't do all this also, never mind. You can straight away give the answer. Then for part B, 0, 1, 0, 0, 1 also the same. 0, 1, 0, 0, 1. This one you see, if you don't do all this step, if you cannot, you do lah. But if you straight away see from the question 1B, you can get the answer straight away. Okay. You see this is S0, S1, S2, S3, right? We start from different steps. So if you refer to your question 1B, this one, you can see that, okay, I go for 0, 1, 0, 0, 1. Start from S0 just now. 0, 1, 0, 0, 1. S2, right? If you start from S1, then you will have 0, 0, 1. Then come here, 0, 1. So if you start from S1, the answer is S3. And if you start from S2, then you will have 0, 1, 0, 0, 1. Then your answer is S0 if you start from S2. And if you start from S3, so you have 0, 1, 0, 0, 1. So answer is S1. Can you understand that? That is how you get this. Try to see, you understand that? Can you understand? 1110 1110 also the same. Here you can start from 0, 1 to 3 lah. This one, the 11100 also refer to the question 1B. Okay, so if you see the question 1B, 11100, right? Let's say you start from S0, yeah. So after input 1, you get S1, and S1, after input 1 again, S2, so S2, 1 again, S3, and then 0, 0 is S3, 0, S3. So if you start from S0 for 11100, the answer is S3. Okay. If you start from S1 for 11100, then you have 1 here, come here, 1 here, come here, 1 here, come here, 0, 0. So S1 answer is S0. And S2, if you start from here, then you have S3, input 1, input 0, and then another one is S1, input 1 again, then come to S1, 0, 0. So answer is S1. Okay. This one, S3, so you have 1, 1, 1, 0, 0. So S2. Okay. So check your answer, is it correct or not? For this part here. After input 11100, 3012, 3012, right? Yeah, correct. So this is the final answer lah. These are all the steps. And for the this one is what? Is part C, right? Part C, they ask you to describe the set of binary words. This one, how do you describe? Is it done by Jia Yi? Jia Yi? Jia Yi, are you here? Set of binary words where the number of 1 is the factor of 4 have the property that, how do we know that S0 will go back to S0? The string that you want to write now is for the W, right? Is for this, right? The W, right? Yeah. So your W is the number of 1 is the factor of 4. Factor of 4. What is factor of 4?
is like if if S0 want to go back to S0, right? You like need to have at least 4 1. Yeah. Then
But
0 also can then 4 or 8.
Is that means factor of 4?
Maybe I write wrong.
If normally we do mathematics, we want to find the factor of 4, what is the answer? Class, what is the factor of 4? 2. What else? Factor of 4 beside 2, we have 1. 0. 1, 2, 4, right? Yeah. So the 1, 2, 4 will be the factor of 4. But in this case, just now you say you have 4, 1, right? 4, 1, and then you have 8, 1, isn't it? But you don't have 2, 1. Yeah. So we won't write it as the factor of 4, but we can write it as the multiple of 4. Okay? Or you can say that the number of 1 is divisible by 4. Either one, but cannot be the factor because it cannot be 2. It's the multiple of 4. Or you can say divisible by 4. Divisible by 4. Okay, so the number of 1, it is either 4, 1, 8, 1, 12, 1, and so on. Then we will get back to S0. This, again, we need to refer to the question number 1b. Here, when you see the table, this question B, right, you can see that the S0, how to go back S0 here. From this, I can go back here, S0 also, or I come here, S0. Meaning, if I go here, then my string will be all 0, right? Nothing, okay, all 0. And if I come here, then my string will be 1, 1, 1, 1. So at least I have 4, 1 to come to the S0 again. That is the question asked just now. Because they ask F, W, S0, go back S0, what is the input string, right? So now we need to find what is the input string here in order that when I start from S0, I will end at S0. So in the table here, we have 2 S0. One is here, one is here. If I end at this S0 means that my input string will keep on input 0 on here, right? So how many 0 also doesn't matter. It will always stop at S0. Okay? But if I come here, then my input 1 will be affected already. So from here, I need to have 1, 1, come to S1, 2, 1, come to S2, 3, 1, come to S3, and number 4, 1, I will come to S0. So when I come to S0, right, I will come back here again. I will repeat the same thing again. 4, 1, come here again. So in between, if let's say in between 1, you have 0. Let's say 1, then 0. So 0, you will remain at S1. And then 1 again, 0 again. So you will remain at S2. 1 again, come S3. 0 again, you will remain at S2. So another way to say is only the input 1 will bring you to the next step, but not the input 0. So if your string is 1, 0, 1, 0, 0, 1, 0, 1, no matter how many 0 in the middle here, it will not affect your final answer as long as the number of 1 here is divisible by 4. You will always be able to come to S0. You can try. Here, 1, 0, 1, 0, 0, 1, 0, 1. As long as you have 4, 1 or multiple of 4, add 1, 0, 1, then you will always go back to S0. Okay? That is how we write the input string for the bill. Just now that one. Why we write it as the number of 1 is the divisible by 4, and why we write it as the multiple of 4. Okay? So that the final answer, it will always go back to S0. Okay? So we have done until this part. The notes we cannot. The rest I will teach again tomorrow. Then hopefully you can finish it. Because tomorrow we have 2 hours, and after that we have Thursday another hour. So I hope we can finish this chapter. Then you see you have any question to ask about? I will take attendance. Abdullah,
Yes.
Inun,
Yes, sir.
Kayal, Kayal. Sleep again. Jising,
Yes, miss.
Zengi,
Yes, miss.
Lee Song,
Yes, miss.
Jackson.